on there. Great. Well, it's great to be here to give you an update on the O'Malley DNA project, which has been running for quite some time now. The last update was at the Clan Rally in 2 years ago in Galway. So a lot has happened since then. Hello, Owen. Sorry, not Owen. Andrew, yes. My cousin, my fourth cousin's in the front row. So it's great to be here, and thanks for having me back. This is going to be, all the slides are going to be on a handout, and if you want to take a photograph of that, then that is the O'Malley DNA blog, and they'll be going up there, the handout will be going up there in due course. Please feel free to take any photographs during the presentation or to ask any questions should you so desire. I may answer them straight away, or I might park them till the end of the talk. So that's where the handouts are going to be going of all these slides. And 2 years ago we talked about the DNA project at Galway Castle, and that is a YouTube video, and that is the connection to the YouTube video. When you download the handout, if you just click on any of these links, then it'll take you to that particular YouTube site and you can play the video. It's out of date now because a lot of things have happened, because after the last gathering, a lot of things happened which I'm going to tell you about. This is the O'Malley DNA website at Family Tree DNA. That's the link there, that'll take you there. And you can simply just Google FTDNA and O'Malley and you'll actually find it. The aims are to answer specific questions that a lot of us will have about our family tree, such as to which O'Malley or Maley or Maley individuals am I most closely related? How will this help me with my own family history and push me back an extra generation or two? Also, of course, connecting with cousins who might have family stories that your family never heard about, and family photographs that your family never had. So it's a great way of connecting with people. From where does my own particular Maley branch originate? Is it possible to link my O'Malley branch to ancient genealogies as described in the ancient annals, and maybe even Grace O'Malley herself? And what can DNA tell us about the deeper origins and the evolution of the surname and where it came from, and what variants it went through, and what does the larger family tree of the O'Malley surname look like, going back to the origins of the surname itself. And of course in Ireland that was about 1,000 years ago that surnames started emerging, and of course it took another 100 or 200 years for them to gain general acceptance. It occurred a lot later in England, maybe around about 800 years ago, and in some parts of England, say in Wales, even up until the mid-1850s, there wasn't inherited surnames. They had the system that still is present in Iceland, where Peter is Ericsson, and Peter's son John is Peter's son, and John's son David is David Johnson. So the name changes every single generation. We also have a new Facebook group, the O'Malley Genealogy Forum, where we have over 100 members now, and that's a great place for swapping stories, asking questions, and reconnecting with O'Malley clan. We also have this new blog called the O'Malley DNA Project, and that's where I'm doing much more detailed updates on each of the genetic groups within the DNA project. This is the recruitment graph for the O'Malley clan. You can see we started here back in June 2005, and it kind of trundled on for many years until June 2017, the Galway O'Malley clan rally, and you can see we shot up after that, and we had about almost 50 people joining the DNA project in the year following the last O'Malley clan rally. And then last year we had about 22 people joining. So it's looking very healthy, and we're accumulating more members all the time. And there is value to be had in numbers. So we currently have 125 members. About 71 of them have done the Y-DNA test. Y-DNA comes from the Y chromosome. Y chromosome is only passed on from fathers to sons, so only males, only men have the Y chromosome, and therefore it's only a men-only test. If you're a woman, you have to find a man and get them to do the test on your behalf as your proxy. I always say behind every good Irish man there's an Irish woman with a knife in his back saying, "You will do that test, dear." So The best way to join the O'Malley project, if you haven't tested yet, men do the Y-DNA37 test from Family Tree DNA. I've got about 20 kits here with me today, so if anybody's interested in doing the Y-DNA test, then they can get that, and Family Tree DNA give me a discount of $40 altogether, so it's $129 for one of those Y-DNA tests. For women, you can still join the project, and women are key to the O'Malley DNA project, largely because it's often the women that are the genealogists within the family. They're the family historians. But number two, they're also very persuasive with the men, and they can get the men to do the test. But also they can do the test themselves. They can do an autosomal DNA test, which is a DNA that looks at all of your chromosomes, all 46 of your chromosomes, and is a very good test just for general genealogy, connecting you with all of your ancestral lines. Whereas the Y-DNA test just does father, 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 father. One specific line. And to join the O'Malley DNA project, then you simply log in to Family Tree DNA, find the O'Malley DNA project, and then just click on the join button in the photograph, and that gets you access to the project, and then I'll be able to see your results and give you an account or an assessment, an analysis of how they fit in to the wider DNA project. And like I said, we have DNA kits available today. So let's look at the results, and I will try and be brief. It's not one of my strong points, but I will be as brief as I possibly can. These are the results from 2 years ago. And at that stage, there were only 3 groups. The group number 1 came from Galway, and their membership has since increased from 2 people to 3 people. Group number 2 came from Limerick, and their membership have gone from 6 people to 10 people. Group number 3 came from Mayo, and they've gone from 13 to 32 people in that particular group. We also have a new group, no idea where they came from, and we have 3 people in that particular group. And we have a group of Mayo, Galway O'Malleys, and we have 2 people in that group. So we're seeing new genetic groups all the time. And this is only to be expected because when you look at the history of surnames and the history of how that Y chromosome is passed on through the generations, there are various ways where you can see a switch either in the DNA or a switch in the surname along that route from 1000 AD to 2019. And then there's quite a few O'Malleys that are in an ungrouped section, and that either is because they belong to a very rare branch of the family, and they're the only person on that branch to have tested so far. And what we're seeing, and we've seen that with group 4 and group 5, some people were previously in this ungrouped section, but then a new member joins the project and they match somebody in the ungrouped section and they immediately come out and form a new genetic family. And that's happened twice in the last 2 years. We have group 4 and group 5 who were previously just a single person in the ungrouped section. The other reason why we might be seeing O'Malleys here in the ungrouped section is because there's been a surname or DNA switch, sometimes called an NPE, which stands for non-paternal event, or not the parent expected. And there are a variety of reasons for why you may not have the parent expected along that direct male line. People immediately think of, illegitimacy, infidelity within marriage, adoption. But there were a lot of other reasons way back in the time of the Irish clans that could result in a surname or DNA switch. And here's a great example, and this is Anne Chambers' book, which is available on Amazon. This is the Kindle edition that I bought, and there's the 40th anniversary edition that's just come out recently. But she has this amazing quote, which says, "Grace eventually became a matriarch, not merely of her own followers and extended family, but of the neighbouring clansmen, whose chieftains had either died in the numerous conflicts of the period, who had abandoned their obligations to protect their dependent followers." So Grace O'Malley gathered the local people who were in need of her support. And what did people do as a sign of an allegiance to the chief? They changed their name from whatever it was to O'Malley, or whatever the local chieftain was at that particular time. And this is going back more than 400 years, so we're looking at 500, 600, 700 years ago. And this is a time in Irish history where there isn't a huge amount of documentation. But this would have been a very, very prevalent type of social behavior that took place. And it's another reason for why we see so many different people with the name O'Malley who have different genetic signatures. It may mean that 700 years ago they weren't O'Malleys, they might have been Joyces, for example. And to show allegiance to Grace O'Malley or her kinsmen, they changed their name to O'Malley, but they passed Joyce DNA down to their sons, who passed it down to their sons, and so on. So there's likely to be many new O'Malleys emerging over the course of time, but I like what Shakespeare said about O'Malleys in Romeo and Juliet, Act 2, Scene 2, where Romeo said, "An O'Malley by any other name would smell as sweet." And the message to take from that is, an O'Malley is an O'Malley is an O'Malley. And if we look at imagine the evolution of the O'Malley surname over time, you will get these DNA switches. So Joyces might become O'Malleys, O'Malleys might become Joyces. It works both ways. So it means that over the course of time, you do see these DNA switches. Here's a few examples. And you also see surname switches. So maybe an O'Malley became a Flaherty to show allegiance to the local O'Flahertys, or to guarantee that he and his wife, who was a Flaherty, would inherit the land. And a perfect example of it would be Morgan O'Brien, who married Eleanor Butler in 1690 or so. He changed his name from O'Brien to Butler so that they were guaranteed of inheriting the Butler lands. And all their children, of course, would have been called Butler, but they would have had O'Brien DNA. So that's another example of how the surname or the DNA can switch. And another thing to keep in mind is that not everybody who was born an O'Malley has living descendants today, because some lines died out. Some men only had daughters, and of course the daughters don't have any Y DNA to pass on. So you get this limited snapshot today of what was happening back in the past, because we can only take DNA from living people, or at least currently we're mainly taking DNA from living people, but there are some people who are beginning to look at the possibility of digging up long dead ancestors and taking their DNA. So the Barrymore project is looking at the 5th or 6th Earl of Barrymore, who was in a mausoleum in Cork, and they went into the mausoleum and they've got permission to extract DNA from some of the bones there. So this is going to happen more and more, that there will be inquiries made about, can we test that artifact from 1400 to see if that's O'Brien DNA, and does it match the O'Briens living today? So let's look at each of the groups within the project, and the sort of questions we can ask ourselves about each of these genetic groups of O'Malleys is, what is the dominant surname or surname variant? Have the members been accurately grouped together? Are we actually grouping people with the same genetic signature? And that's very important, because we run into the problem of chance matches with some of the groups, and I'll illustrate that later on. And most of these chance matches are due to something called convergence, which I'll talk about briefly. Are there any surname or DNA switches? And if so, which came first? Was it the O'Malley chicken or the Boylan egg? These are the kind of questions that we have to ask ourselves. Where is the group from? So this is really important, especially for people of the diaspora, who might know that their ancestors came from Ireland, and that's as far as they know. But doing a DNA test can actually tell you which particular genetic group of O'Malleys you belong to, and that helps focus your research on Mayo, or on Limerick, or on Galway, or on Kilkenny. And in order to look at this particular question, we look at our match's most distant known ancestor birth locations. So where was the most distant known ancestor born? And also the surnames associated with your matches. And extensive pedigrees can be very, very helpful as well. Sir Conor O'Brien has a 32 generation pedigree that goes back to Brian Boru, documented all the way back to Brian Boru. And he did his Y-DNA test, and it matched a whole bunch of O'Briens that were proven to be Dalcassian in origin. And that was a very good way of further corroborating that the Y-DNA signature of the O'Briens was the particular one that had been found. We can also ask, how old is the group in terms of how long have they actually been carrying the DNA associated with the O'Malley name? And that we'll look at that when we come to group 2, which are the Limerick O'Malleys. And the question there is this the DNA of the person who originated the surname 1,000 years ago? We look at pedigrees. We can look at the tip report tool, which is a tool on family tree DNA. We can date SNP markers, which are another type of DNA marker on the Y chromosome. And we can develop things like the mutation history tree, the MHT, generated via the SAP program, and I'll show you some of that as well. The last question is really quite an exciting one, is the O'Malley surname associated with a specific Irish clan? And in order to answer this question, we have to look where each of the genetic groups sit on the overall tree of mankind, and we'll have to look at their nearest genetic neighbours, especially those that are likely to have risen before the time of surnames. And does this tie in with anything that's written in the ancient annals? So these are the type of questions we can ask when we're looking at each specific genetic group. And to look at that last question, we look at the big Y tree and also haplogroup projects. So you can see that this type of analysis draws on a lot of different information and tries to collate it all and present it as a relatively simple message. Sometimes it's easier said than done, and it does take a lot of data, and we are part of the way there with a variety of the genetic groups. And the first of these genetic groups is group 1, and this group, the predominant surname variant is O'Maley, M-A-L-E-Y, and all of these people come from Galway. And you can see it written up there, they've actually put their most distant known ancestor's birth location. So it tells us that they're from Galway. They're all third cousins to each other, and their most recent common ancestor dates from 1845. So what we can say is that all three of these people have been bearing the O'Malley name since 1845. They all have the same genetic signature. It doesn't tell you anything about what happened to this group before 1845. Did they still have the O'Malley name before 1845? Or back in 1845, did they actually take their mother's name because the father had abandoned the family? And the sons took the mother's name, and that's how the O'Malley name became associated with this particular genetic signature. So that's the limitation of the DNA. It only tells you about the association between the O'Malley name and the DNA back to that particular time, which is 1845. Is this the DNA of the name originator? Well, the rate of these surname or DNA switches, or NPEs, non-paternal events, it's about 1 to 2% per generation. So if you imagine that there are about 33 generations back to about 1000 AD, you can arrive at some approximation of a probability that the name goes back to the originator. There's probably a 33% chance in this situation that there was a switch in the surname. But against that, there's a 67% probability that it actually does go all the way back to the person who originated the surname. So we're dealing with probability, and nothing is 100% guaranteed, not even with DNA. This is their string of letters. These are their STR marker values. You can see it's just a string of numbers. And you can see also where the mutations occurred. And this is their family tree. We can see that their most distant known ancestor is John, born 1795, but because they're third cousins, their most recent common ancestor is Michael in 1845. Over the course of time, there were no mutations from Michael, because we can calculate what his genetic signature was from the genetic signature of these people. We can say that it was probably 22 for this particular marker, and there's a mutation there. One of the three cousins has had a mutation from 22 to 23. So that way we can map the mutations over time. No mutations on John's line, 2 mutations on James's line. This one here, 22, and this one here, 12, and one mutation on Joseph's line. and Joseph's line would be this one here, where there's a mutation at 23. So this just gives you an idea of how mutations can occur over the course of time as the DNA is passed from father to son to son. And that gives you a genetic distance of 2 mutations between these 2 people here, 3 mutations between these 2 people here, and only 1 mutation between these 2 people here. And that's just an explanation, a visual explanation of genetic distance. And it's just a measure of how closely related people are to each other. But you can see also it's really just a genetic lottery whether mutations actually occur on a particular line of descent. They've also tested, one of them has tested on the big Y, and their terminal SNP is BY37245. And this is a SNP marker, and SNP markers are a different form of DNA marker. There's 2 types, STR, which is the string of numbers, and SNPs, which are just this single DNA marker. And this is the position of BY37245 on the tree of mankind. There's the top branch, the branch above it. You can see that BY37245 is 1 branch below that. Here's another branch, be adjacent to it, which splits into 2 more branches. This one splits into 2 more branches as well. And this is a summary of the tree of mankind. We can also give rough dates for when these branching points occurred. This one happened about 700 years ago, this one about 3,000 years ago. So the nearest genetic neighbors to this particular branch of O'Malley's are 3,000 years ago. So these O'Malley's are actually sitting on a very isolated branch of the tree of mankind. And that's very different to what we'll see when we start talking about people who are related to Niall of the 9 hostages. Watch out, group 3. We can also look at these genetic neighbors to look at their surname. And you can see these Maleys are related to an O'Brien. And then among their matches, their STR matches, we have O'Brien, Cashin, Gleeson, and Nealon. And if we map these genetically related surnames on surname distribution maps, and these ones are from John Grenham's website, which uses Griffith's valuation in the 1850s, you can see that there seems to be a concentration of them perhaps somewhere in this North Munster area. So on that basis, what we would be able to say about group 1 is that there is a suggestion that they probably come from somewhere in the North Munster area originally, the deeper origins. So these are 3 third cousins. The O'Malley name was carried until 1845. What happened before that, we don't know. They have origins in Galway, deeper origins probably in North Munster. Before that, because of its haplogroup I, we know these to be pre-Celtic. So these may have been the hunter-gatherers or the farmers that came into Ireland rather than the Celts and that so-called Celtic conquest of Ireland in, say, 1,000 or 2,000 years ago. Sorry, 1,000 or 2,000 BC. So we need more matches, and we need to encourage some of these genetically related surnames to do the big Y test, which is the creme de la creme of the Y chromosome tests, and that will give us more information. But this is a similar situation to many of the genetic groups. You have a small number of people, and really we need to get more data before we can draw any more conclusive conclusions than the ones we have here. Group 2 O'Malleys. Now these O'Malleys, the dominant surname is O'Malley. The origins are Limerick. You can see everybody here has Limerick as the most distant known ancestor's birth location. They go back to about 1650, and I'll show you how we come to that. And they have a SNP marker that places them on the DC735 branch of the Tree of Mankind. These are their mutations on their STR markers. You can see there's a few here, one there, one there, one there. There's 3 down here. They're a relatively closely knit bunch of people. How old is the group? The pedigrees go back to 1780. So they take us back to about 1780 or so. The TIP report, which is this tool on family tree DNA, calculates that it could be anywhere from 1650 to 1830. you can see how crude that is. You know, it's exact, it's accurate from a statistical point of view, from a genealogical point of view. It's not very exact, and it's not what we want. We want to know, well, is it the great-great-grandfather or the great-great-great-grandfather that we're talking about? So we have to always interpret these calculations and estimations with a great grain of salt. But based on both of these, I'd say the common ancestor probably lived sometime between 1650 and 1780. So let's say about 1700 for this particular group. So we can say that this particular group has carried the O'Malley name associated with this DNA for about the last 300 years. But what happened before that? 300 years ago brings us back to 1700. We don't know anything about what happened between the founding of the O'Malley surname 1000 AD and the period from that up to 1700 in this particular group. And there could have been a surname or DNA switch, or maybe one or more, around that time. Were these O'Malleys from Limerick descended from Grace O'Malley? Did Grace O'Malley's clansmen come down to feed her while she was imprisoned in St. John's Castle? And because that's what they had to do. If you were put in prison, you relied on your family to feed you. And that means that O'Malley young men are down here looking at fine Limerick women, and one thing leads to another, and suddenly the O'Malleys of Limerick have been born. Or was it a case that it was O'Sullivan Bear? This is another theory that I've heard over the weekend, is that on the retreat from O'Sullivan Bear, some O'Malleys stayed in Limerick. Were they originally from Mayo, and then over the course of time, there was a DNA switch, and they switched to this Limerick O'Malley signature away from the Mayo O'Malley signature? Or was it simply that the O'Malleys of Limerick are a completely different sept, different clan to the O'Malleys of Mayo, and they arose completely independently of the O'Malleys of Mayo? We don't actually know the answer to this question. Brendan mentioned earlier that there are some references to O'Malleys in Limerick dating back before the time of Grace O'Malley, and it may indicate that this was, well, there was the chap who was mentioned in the book from about 1780, but there was also a possible O'Malley, I think, in a Franciscan friary or that sort of thing, going back possibly to 12, 13, 1400, you know. Mungret, yeah. So again, was that O'Malley originally from Mayo and somehow moved down to Limerick, or was this an indication that the Limerick O'Malleys were a separate sept? As we get more people joining this group and more people doing the Big Y test, these questions will be answered. 3 people have done the Big Y test already. You can see them there with the orange circles. And it places the O'Malleys here on the tree of mankind. These are their next door neighbours: Curry, O'Hara, Hare, O'Loughlin, Griffin, McInerney, Slattery, McNamara. And then when we look at the Big Y block tree in the L226 haplogroup project, we can harvest more surnames of genetically related individuals: Neely, Roach, James, Hartigan, Klein, O'Brien, Corrie, Slatter, Slattery, and a few other ones here. If we look at surname distribution maps, we find that there tends to be a preponderance of origin in and around the Galway-Limerick area. And this means that the deeper genetic origins are probably in the Clare-Limerick area, and that's not too surprising because L226, this upstream SNP marker, is the ancestor of Brian Boru. And of course, Brian Boru's clan territories were in the Clare-Limerick area. So it's all pointing to a Clare-Limerick origin for this particular genetic signature of the O'Malleys of Limerick. And Wolfe, in his surname dictionary, says that the O'Malleys, 2 sources, one was Mayo, the second one of a Thomond family who were chiefs of Tualimni, a district in the neighbourhood of the city of Limerick. And if they were chiefs of Tualimni, there's another reference to them in Begley's book. Tualimni, about the noble Shunnen, 2 chiefs are over it on one side, O'Keely and O'Malley the swift, beautiful ravens of the two invers. And that was from O'Hireen's poem as recorded by O'Dugan. And he makes the comment, that part of O'Malley's land would correspond with the parish of Knocknagowl. And here is Knocknagowl on the map, and you can see it is directly south of Limerick City. So this would have been part of the Tualimni territory, and this could indicate that the O'Malleys, in fact, have been there for a long, long time. It would be fascinating to know where Wolfe got his information from, because this is taken from 1923. Well, and he would have relied completely on oral history, to an extent also on the ancient annals. But I don't think he was a medievalist per se, so he wouldn't have studied them in any great detail. Edward MacLeisett might have been more of a person to do that. And of course, a lot of the ancient annals, they would have been written in an older form of Irish, so you'd have to be quite specialised to read it. So here is a mutation history tree for Group 2, based on the genealogies. So you can see they've all supplied their genealogy, and this tree goes back to the most distant known ancestor for various people. Then we've mixed it in with the STR mutations and the SNP mutations, so when the ancestors run out, we're using DNA mutations instead to define the branching structure of the family tree for Group 2. And this is the type of thing that we get, and we can see which mutations are shared between the different branches. And there's 3 main branches, this one here, this one here, and this one here. And we can see the unique mutations that each branch have as well. And this is just a way of collating the data. We can also add in autosomal DNA data to this chart, and this is what you get. It's called a McGuire chart. Again, you've got your 3 branches. I've called them A, B, and C just for convenience. And this is the amount of autosomal DNA that is shared between each of the branches, each of the people, expressed in centimorgans. It's just the unit of quantification. And from this, it helps to estimate relationships at the level where you're running out of data. So it can be quite useful. There's 2 caveats. People had a habit of marrying their cousins, especially if they were from small, isolated rural communities. And practically everywhere in Ireland was a small, isolated rural community. So you are going to get a lot of cousins marrying cousins, and that can muddy the interpretation of the picture. At a later point in time, once we get a big enough size, we can use something called triangulated segments, and we can actually track specific DNA segments through time and through lines of descent, which would actually help prove that 2 particular branches were related by a common ancestor. But that's something for later on. The importance of this is how women can actually get involved in the project, because we can use women's DNA in this type of chart as well. This is actually just the men involved, but women will have autosomal DNA as well, and we can also add women O'Malley descendants to this particular chart, make it a lot bigger, of course, and that also allows us to interpret the data and see which of these branches are more closely related to each other. So that's just something that DNA can do. It does take a lot of work, and you need a lot more people than we currently have to do this type of work. So to summarize with the Group 2 O'Malleys, they're about 300 years old. They've been carrying the name and the DNA for about 300 years, but what happened before that, we simply don't know. The deeper genetic origins appear to be in the Limerick and Clare area as far as the DNA goes. It's Dalcassian. Maybe the chiefs of Tualimni were originally Dalcassian. And we've seen how the mutation history tree in the McGuire chart can show possible connections between different members. But we need more matches, more big Y data in particular, and we need to add more autosomal DNA data to that last McGuire chart. So these are things that can be done in the future. Skipping on to Group 4, because I'm going to come back to Group 3, there are 3 people in Group 4. They seem to come from Kilkenny. We have Kilkenny, Castlecomer, and Kilkenny there. One of them, this one up here, the first member, is likely to be a second cousin matched to the second member. They've probably carried the name since about 1791, according to their pedigrees. That's as far back as this one here goes. And then the tip report calculates the time to the most recent common ancestor as about 1860, with a 50% probability, and 1710 with a 95% probability. So we're probably looking at a common ancestor sometime in the 1700s. Where do they come from? The pedigrees suggest Castlecomer, but they have done a big Y test. Two of them have actually, and that gives them the SNP BY70535. Where is that on the Tree of Mankind? Here it is here. It's about 700 years old, and then the nearest neighbours before that are 1,450 years old or older. And you'll notice that there's a big bunch of them that are Scottish, and the other ones are Irish. And if we put the Irish names into surname distribution maps, we find that this is kind of Kilkenny, this is near to Kilkenny, this is Kilkenny, this is all South Munster really. There's nothing, well, there's a little bit of Kilkenny there. This one is Clare and Clare, Galway and Clare, and this one is Antrim and Down. So, you know, we can't draw a huge amount of conclusions from this. There are four possible origins: Kilkenny, Down, Clare, or Scotland. And it's because the nearest genetic neighbours are more than, the common ancestor is 1,450 years ago or more. Ideally, we want to get it to maybe 1,000 to 1,500 years ago. And that would give us a better idea. So at this stage, we don't know where group 4 comes from. We know that they probably go back to Kilkenny in the 1700s, but before that, where did they come from? Where did their DNA come from? We need more matches, we need more big Y data. Group 5 of the O'Malley's, this is newly formed, only within the last 2 weeks. And there are 2 members, and they are separated by a genetic distance of 4 out of 37. You can see those 4 mutations there in their STR markers. And the oldest MDKA, most distant known ancestor, is 1840 for this particular chap here from Kilmilken in Galway. So this is one of the Kilmilken O'Malley's. And the TIP report estimates that there's a 50% probability that they are related in 1770, 95% related sometime after 1530. So we're looking at somewhere between 1530 and 1770 for the common ancestor for this group. The interesting thing is that 70 to 80% of their matches on their matches list are Joyce. They have the surname Joyce. So there's this very, very strong association with the surname Joyce. Other surnames that appear in their matches list include Coyne, Newell, and Nally. We put them all into surname distribution maps, and we're getting a very, very nice concentration around the Galway area. And in fact, Joyce country is right here in green, and Kilmilken lies right within Joyce country. It's the yellow dot there. So possibly there's been a surname or a DNA switch at some point in time. For example, a Joyce man marries an O'Malley wife and changes his name to O'Malley to show allegiance or to guarantee that he inherits that the O'Malley land that his wife is due. So that's group 5. We still don't know which came first. Was it the Joyce DNA came first, followed by the O'Malley? I suspect it was the Joyce, and then followed by the O'Malley. That's the surname switch, but we need more matches in this group. We need more data. Group 3 O'Malley's. We finally come to the group 3 O'Malley's, and these are 32 altogether. The main variant is O'Malley. You can see it here, 16 of them are O'Malley's, but there's a variety of different possible surname variants, including ones like Mellon, Melia. We have a few Melias this weekend as well. Even Molloy and Malloy occur as surname variants within this group. Most of them come from Ireland, and the majority come from Mayo, but you can see that some come from Galway, one from Donegal, Dundalk, some from Ulster. There's also Renfrew in Scotland, Liverpool, and Middlesex. And the various SNP progressions have been delineated since the last clan rally, because this group 3 Malloys, a lot of them have done additional SNP marker testing, and we get these branches, these SNP progressions for each of these SNP, the terminal SNPs for the various groups, and it's created 6 subgroups. And they're all on different branches of the Tree of Mankind. And here are those 6 subgroups. here is the diagram of the tree of mankind, showing where each of the SNPs that they have along the way. And if you look at the very, very top, this one here, you can see that the earliest known ancestor lived, or the most recent common ancestor to the entire group lived more than 1900 years ago. And that's well before the time of surnames. So there's no way that the O'Malley name in each of these 6 groups arose from the same single origin. It has to be from separate origins. And this is a real problem with this particular branch of the tree of mankind, M222, because it's associated with Niall of the 9 hostages. And what was he and what did he do? He was a warlord. He comes in, he annihilates the countryside around him. He has 10 sons who have 10 sons who have 10 sons, and they just take over the entire place. And with that amount of descendants, you're going to see many, many more mutations. They're all happening at the same rate in each descendant, but if you have only 5 descendants, you're not going to have as many mutations as you would do as if you had 500 descendants. So that's why you see this kind of explosion of different branches underneath this particular SNP marker, which is associated with Niall of the 9 hostages. A big problem with this, of course, is that we get a lot of chance matches, because as the Y DNA is passed down from father to son over the centuries, and you get all of these mutations occurring, some of the genetic signatures in one branch start to look like some of the genetic signatures in another branch. And you get one branch encroaching on the other branch, and it means that people in one branch start matching people in another branch, and they think, oh, we must be closely related because we've only got a genetic distance of 3 out of 37, when in actual fact, the common ancestor isn't 200 years ago, it's 2,000 years ago. And that's what happens when you get a massive warlord having massive amount of descendants with lots of mutations. It's good to just at this point remind you of the genetic distance thresholds for matching. So if you open up your results, you have a list of matches, you only get a match put in that list if they have a genetic distance of up to 4 out of 37 markers, 7 out of 67 markers, or 10 out of 111 markers. So those are the thresholds. If somebody is 5 out of 37, they will not appear in your match list. If they're 8 out of 67 or greater, they won't appear in your match list. And similarly, 11 out of 111 won't appear in your match list. And if you imagine these STR signatures mutating like ticker tape, you know the ticker tape with all of the stocks and shares, and you can see them changing as time goes on, generation after generation. And imagine that one is mutating that way and another one is mutating this way, but then this one decides to start mutating this way, and then suddenly they start looking like the ones that mutated over here. So that creates confusion. And that's why convergence is a real big problem, because it means that people look more closely related to each other than they actually are. So if we look at the various subgroups of group 3, we have group 3E to start off with. There's only one person there. His name is Maley, and he matches a Maley, a Maley, and a Meloy, all with a genetic distance of 7 out of 67. So they all appear in his list of matches, which is why I grouped him with group 3. But it turns out that if we look at the number of matches he has 9 matches at the 111 marker level. He has 1,729 matches at the 67 marker level. That's huge. It's far too much. And by doing the majority of those, 90% of those would be just chance matches. If we look at his terminal SNP, it's BY71053. It's more than 1,100 years old. The most recent common ancestor with the nearest genetic neighbours is 1900 years ago, and there's a possible Scottish origin for this particular chap. So I won't say much more about that. The next one is a Malloy, and he matches a Millie and a Meloy. And again, he has 1,538 matches at the 67 marker level, far too many. There's probably chance matching going on here due to convergence. His most recent common ancestor with the nearest genetic neighbours is more than 1900 years ago. And this particular chap is in the Maley project, and he matches 16 other people. And by doing some analysis on that particular group, we have established that they are very, very likely to go back to the Fircal Maloys from Roscommon. Is it Roscommon? The Maloys in Roscommon? So he is a Maley rather than a Maley. The next one, group 3C, he matches Amelia, genetic distance 4 out of 37, so it's a match. But again, there's a huge amount of, he has 79, 1,194 and 1,004 matches at the 111, 67 and 37 marker level respectively, and that's far too many. The majority of them are going to be chance matches. So he is just matching this Amelia by chance. And again, his nearest genetic neighbours, the common ancestor is over 1,850 years ago. But there's a possible Scots-Irish origin to that particular group. In fact, if we look at this particular group briefly, you can see that here he is here, Maley, but look, he's matching Kilcoyne and Craig, Galloway, Dunaway, Galleon, Gallagher and Bain. And if you put those into surname distribution maps, you're really beginning to see a concentration around the North Antrim Down area, Northeast Ulster area. So it could be Scots-Irish for this particular chap. And if you do a little bit more detailed analysis, then Down and Antrim come out on top as possibly the most likely sources for the deeper origin of this particular group. So possible Scots-Irish origin, and here are 3 surname distribution maps that show you the distribution of Malloy, Melloy and Milloy in Britain and Ireland. You can see that there tends to be a concentration in the lowland Scots area. So again, suggesting that there is a kind of Scots-Irish origin for this particular group. And it's a nice demonstration of how you can use the genetic neighbours to tie in to surname distribution maps to give you a clue as to the possible origins. Group 3B, again, also has possible Scots-Irish origin. I'm not convinced the members are correctly grouped together, because if you look at the genetic distance matrix, just put all of the genetic distances into a matrix, it comes out with this massive difference of 16 out of 111. For this particular one, 4 out of 67, that's probably reasonably okay, which means the second and third one are probably correctly grouped, but there's a disconnect between the second and third member and the first and the fourth member. So again, we need to do more DNA testing, particularly big Y testing, to actually find out whether these people have been grouped correctly and then where they have come from. Now, the interesting thing here is if you look at this, there's 69 matches at the 67 marker level for this particular Maley 7064. If we just look at these 69 matches, 27 of them have done SNP testing. These are the SNP progressions down to the terminal SNP for all of those 27. And you can see that at least 74% of them are sitting on completely different branches. So that we have now managed to quantify the frequency of chance matches in this particular group. It's at least 74%. I suspect it's closer to 90%. And it just goes to show how difficult it is to draw conclusions when so many of the matches you're looking at are just chance matches. Trying to separate the wheat from the chaff is actually very, very difficult. So, to summarise in Group 3B, possibly Scots-Irish origin. Other genetically related surnames include Kerr, Graham, Lamont, McBride, McBrayer, all very, very Scottish. We need more matches in this particular group. We need more big Y data. The second last group, Group 3A1, O'Malley, Scots-Irish origin again, possibly. And they have, again, are we certain that they're grouped correctly? No, we're not. Are we looking at chance matches? We may be. Their one big Y result shows that the nearest genetic neighbours have a common ancestor about 1700 years ago, which is very far upstream. there are 48 branches below that common ancestor, so which one of them are the nearest genetic neighbours? Ideally, we need to get one more person from this group to do a big Y test, so we can come a little bit further downstream on the tree of mankind. Now we come to the big one, Group 3A. These are the Mayo O'Maleys. This is what you've all been waiting for. I'm saving the best till the end. So there are now 20 people in this particular group. This is what their STR values look like. It's fairly close-knit. There are some mutations here and there. It's not a mass of blue and red mutations. You can see that in the middle you get the purest ones, and then you get mutations on either side. These ones here in the middle are likely to approximate the DNA signature of the originator of the DNA of this particular group. The big question is, are these the O'Maleys of Murrisk and Burris Hoole? Do they go back? Are you related to Grace O'Malley? So this is the big question. I used the SAP tool to generate a genetic distance matrix. This is the genetic distance of every one of those 20 members to every other one of those 20 members. And here on the left-hand side, I've put a red for dodgy, an orange for possibly okay, and a green for more than likely okay, to be grouped together. And you can see that there are 3 red ones up here, where the genetic distance is no closer than 7 out of 37, 8 out of 67, and 5 out of 37. So they don't actually appear in anybody else's match list. So, they don't appear in the match list of those people who have been big Y tested. So the arrows here indicate those members who've had the big Y test. And the big Y helps to anchor you on the tree of mankind. So if we compare everybody, especially to the ones who've done the big Y test, so that'll be these people here, this one here, these values here, and these values here. You can see that in order to try and anchor everyone who hasn't done a big Y test, I'm comparing them to people who have done a big Y test and seeing if the genetic distance on their STR markers is within the threshold for matching. And for these people in red, it's not. For the people in orange, it is, but it's only just about. It's at the upper limit. 3 or 4 out of 37, 6 or 7 out of 67, and maybe 8, 9, 10 out of 111. And for some people, here's a genetic distance of 0, so that is an exact match. So they are fine. The green ones are fairly okay. And this is all a little bit finger in the air, but I'm kind of trying to group people on the basis of probability. So it looks to be like most people are probably accurately grouped in this particular group. We just need those 3 red people. They would be perfect candidates for the big Y test because we can't be absolutely sure that they belong here. Also, the fact that they are the most distantly related of this group, if they do match this group on the big Y, we have probably identified an ancient branch of this group. And what that is going to do is that is going to help us date the age of the group. And that's going to be really important to see whether we can go back before the time of Grace O'Malley, even go back to the time of the generation foundation of surnames about 1,000 years ago. Another question we have to ask is there any evidence of chance matches? And you can see here that this person has 1,476 matches at the 37 marker level. Compare that with these people up here who only have 1 match at the 37 marker level. This person here has 665 at the 67 marker level. And these 2 people here, they're cousins. 19 matches at the 111 marker level, which is actually quite a lot. So let's look at that particular individual and let's look at his matches and see if there's any evidence of chance matches due to convergence. And there is. At 111 markers, those 19 people that he has in his match list, at least 80% of them are chance matches, and that's at 111 marker levels. At the 67 marker level, at least 66%, 2/3 of his 254 matches at the 67 marker level are chance matches. And that really creates problems for me, because I cannot be certain that I'm grouping people correctly if the level of chance matches is that high. And that's why we need the big Y data to really anchor these people in the group and anchor the group on the tree of mankind. Now, apart from asking the question, how closely related are the members of the group, we can also ask, how distantly related are the members of the group? In other words, what's the spread of genetic distance values within the group? And I took somebody's DNA to do this analysis, and at the 37 marker level, this particular individual here, which is this first one up here, 3A14. If I do it here, you'll see it better. So we took this chap here who's had his big Y tested, and we compared him to the other 3 people who had done big Y tests. At the 37 marker level, the genetic distance was 3 out of 37 for one of them, 4 out of 37 with the next one, and 5 out of 37 with the next one. You know, that they're all at the outer bounds of, well, the first 2 would be matches. The third one would not qualify as a match at that level, but just outside the level. When we go up to 67 markers, 2 of the other big Y testees have done the 67 marker test, and the genetic distance there is 8 out of 67. That's just outside the threshold for being declared a match. And when you go up to 111, the genetic distance jumps to 19 out of 111 and 13 out of 111, and those would not appear in the person's match list. So we are getting a very wide spread in genetic distance values in this particular group, but you only see it when you test to the higher number of STR markers. Here is the family tree for the Mayo O'Maleys. And this is generated using the SAP program. The most interesting thing here for me is that it goes back to 1400 AD, plus or minus 400 years. Again, you have to be really careful how you interpret these dates. But this is the best guess, the best fit family tree based on the available DNA data. And this is combining the STR marker values with the SNP marker values to give you this family tree. And the numbers here relate to the numbers on the previous slide that I have for the members, the 20 members of the group, where you can see that these 2 people here, they're estimated to have a common ancestor in 1950. In fact, they're second cousins, and the common ancestor was actually 1890, that type of thing. So there is a margin of error on either side that you have to be aware of, but it gives you the relative connection between different people within the entire project. With big Y700 data, we can build even more detailed trees, because we will have not just the SNP markers that help anchor the group on the tree of mankind. We'll also have 700 STR markers that can be used to really get to the granular level and build this mutation history tree. And it'll show us what the structure of the tree looks like. It may give us clues, because if we can get certain members of each branch who have extensive or deep pedigrees to do the project and join this tree, it means that other people can piggyback onto those extensive pedigrees. So it's a lot of work and requires a lot of data, requires a lot of time to put it together, but also a lot of expense of people doing the tests, and also takes it takes a lot of time to encourage people to do this type of testing. But this is the sort of thing that is possible with the big Y data. So what are the deeper origins of Group 3A? Well, the pedigrees say Mayo. Can we use surname distribution maps in this particular instance? Who are the nearest genetic neighbours to the O'Maleys on the tree of mankind? Well, there are 456 nearest genetic neighbours on the tree of mankind, because we're having the Nile of the 9 hostages effect. Lots of descendants, lots of branches, all happening very, very quickly. And we don't know which of those 456 branches is the closest. So it's not going to be practical to look at these genetic neighbours. They're probably all Irish, but that's about all that we can say. So the surname distribution maps cannot be used reliably. Instead, what we do is we turn to targeted testing of men with these deep pedigrees. And the great thing is that we have these pedigrees for the Mayo O'Malley's. This is from O'Hart's Irish pedigrees, or the origin and stem of the Irish nation. The O'Malley's are of the same descent as the O'Connors, kings of Connacht. And they came from the baronies of Murrisk and Burrishoole. Here begins the line of descent from Brian, who was brother of Niall of the Nine Hostages, again in keeping with the M222 snip that we have found. And then Brian's line of descent goes like that down to the O'Malleys. The first to assume the name was Donal Finn O'Malley. So that is probably around about 1000 AD on that particular lineage. And then also Brian's brother gave rise to the O'Flahertys, the McHughes, the Concannons, the Fahys, and the McMorrises. We also have Bartiaski's pedigrees, and again, this shows the line of descent down to the O'Malleys. And we also have the family tree of Grace O'Malley. Here she is here. And she is married firstly to Donal O'Flaherty on that side, and those are all their descendants. And she's married secondly to Richard Burke on this side, and these are all their descendants. They're going to carry, of course, Burke Y DNA and Flaherty Y DNA. But we also have, there's a Donal O'Flaherty and Richard Burke. Donal na Pippa was Grace's half-brother. If he had descendants, and if we can find a pedigree that goes back to Donal, that means we have a line of ascent up to Grace O'Malley's Y DNA. She wouldn't have had the Y DNA, but her father would have had the Y DNA, passed it down to Donal na Pippa, and then it could have been passed down to all of those descendants. There are pedigrees available in the National Library, and here's some of them. And where is the one I'm looking for? Oh yeah, one is there. Copy of the Confirmation of Arms to Charles Louis Connor O'Malley. You might have seen yesterday in the exhibition that we actually have the decree from Edward MacLysett, who granted the arms to Charles Connor O'Malley back in 1946. That was on display last night. And there's other pedigrees that may be associated with the O'Malley clan that we need to get hold of from the National Library and see if we can find a direct male line of ascent that takes us back to Donal na Pippa, Grace's brother, or one of Grace's first or second cousins. So the conclusions after all of that is that there are multiple origins of the O'Malley name. Everyone has about a 50% chance, all of us in the room have a 50% chance that there has been some kind of surname or DNA switch along our line, because it could even have happened at the foundation of the surname. Somebody says, I think I'll take on the name O'Malley, and then he can't have any children with his wife, so he adopts a child, and that child is called O'Malley, but the Y DNA came from somebody completely different. So you never know where that switch is going to happen. There are at least 5 distinct groups of O'Malleys, some from Galway, some from Limerick, some from Mayo. There might even be Scots-Irish as well. We need more people to test. We need more SNP testing, especially for group 3, to see if we can really anchor this particular group, which is plagued by these chance matches, anchor it to the tree of mankind. Ideally, we need at least 2 people from each of those groups that I've shown you to do the big Y test. More research is needed on the historical texts, and I'm not a medievalist. I wish I was. We probably need more people like this to help with the project, to actually find these ancient texts and come up with a research strategy for finding descendants from these ancient texts. And the adventures of the O'Malley clan continue to be continued in 2 years' time. See where we are then. So thanks very much for your attention. If anybody wants to buy a DNA kit, I have DNA kits here. I'm going to stay around, so if you have any questions, please feel free to come up and ask.